In the application of Gauss's law, first we can find what is the flux density due to point charge. Suppose we have a point charge, Q is located at the origin. So what we have to find? We have to find the flux density at the point P. At this point P, we have to find the flux density. So in order to find the flux density at this point P, first step is we have to assume a Gaussian surface. So this charge Q is located at the origin. So we have to find flux density at this point P. We can assume a spherical surface as Gaussian surface. So this spherical surface we can assume as a Gaussian surface. So we know that this is a spherical surface is a closed surface. So we can apply Gauss's law to this closed surface. So according to this Gauss's law, we know that the total electric flux through any closed surface will be equal to total charge enclosed in that surface, or the surface integral of flux density vector over that surface will be equal to total charge enclosed in that surface. So we can apply Gauss's law to this Gaussian surface or this spherical surface. We have to find the flux density at this point. Suppose this is the distance r from the center. We have to find flux density at this point P. So we can apply Gauss's law to this Gaussian surface. So we can write, according to Gauss's law, we know that total charge Q will be equal to closed surface integral d dot ds. So here this flux density d is normal to this Gaussian surface. The normal vector of the flux density is dr. The normal vector of the flux density to this surface is dr. So we can write the normal component of this flux density is d will be equal to dr ar. So in this one, again this normal component of the flux density we can take in this equation. So again we can write Q will be equal to this closed integral dr dot ds, or we can write this closed integral dr take outside dr into ds, or this will be equal to dr into total area of this surface. So this is a spherical surface. Total area of the surface, the radius is r. So total area of this spherical surface, we know that is 4 pi r square. Now this is Q. What we have to find? The flux density dr will be equal to Q by 4 pi r square, or again we can write d will be equal to Q by 4 pi r square ar. So this is the flux density at this point P due to this point charge Q, that is d is equal to Q by 4 pi r square. It is acting along the direction of ar.